meteorology. We've talked about various aspects, but in general, the part we're most interested in, at least practically, is the weather. What is actually going to happen with the types of things going on? And so we'll look in more detail. Again, these days there are plenty of easy online sources where you can find out about what's going on with the weather and look at patterns there. There's some extra option for looking at the weather over a few days you may be interested in that's up on Blackboard as well. Again, don't forget, get things turned in. Keep an eye on the timing for finals. If you're a senior, grades are due a little earlier, though I'm sure with the situation with the virus that will be to some degree flexible as needed. Okay, so we're going to focus in on what causes weather and particular types of weather. So air masses, fronts, and mid-latitude cyclonic systems. These are our big players in determining what actually is going to happen for weather. And we'll look at specific types of weather hazards. So 3 main things determining our weather. Do we have a big mass of air with particular features? That will determine what type of weather is being experienced. These air masses do move around, and the boundaries between different air masses, known as fronts, are places where we have things going on with the weather. Also, local high and low pressure systems. These often are associated with the features of air masses and fronts, but can be more out on their own in the middle of things. Again, wind will blow away from a high pressure area towards low pressure. We can think of high pressure as some place where air is sinking, so it's pushing more on us. We're feeling more pressure. Air can only sink so far. Hits the ground, it has to go out sideways. So wind's blowing away from the high pressure. Low pressure, where air is rising. Air is moving up, it's pushing on us less. And we can still breathe, so if air is going away, more air is to be coming in. So air is moving to the low pressure, away from our high pressure areas. Okay, we'll start with our air masses, and then get to the fronts between them. So an air mass is a rather large body of air with fairly uniform properties. In particular, the temperature and humidity in the air mass is generally roughly the same. How do we make an air mass? Well, if we've got a bunch of air that's sitting in one place for a while, it will get features typical of where it is. Whether it's in a warm place, a cold place, a wet place, a dry place, the air will tend to get hot or cold, wet or dry. And then fronts, the symbols for our boundaries there. Air can warm up or cool down. We can have convection, conduction, radiation occurring that will either warm up or cool down our air depending on where it is. And evaporation, condensation can either add moisture into our air or take it away. Once we've made this air mass, however, they can move fairly fast, several hundred kilometers in just one day. That's faster than they change. So when an air mass moves from one place to another, it's going to bring conditions like where it was to that new location. Now, if that air, once it gets to a new place, it sits and stays there for a while, gradually it will change to match what's more normal for that place. If a place has an air mass on top of it, well then the weather will match the air mass, which means we're going to see the same weather, maybe a slow change, but pretty similar weather for several days in a row, or maybe even weeks if the air mass stays long enough. So here's an example. I got the forecast for here at one point, and sunny, high 61, high 60, high 62, high 61, clear, low 32, 30, 31, 33. It's not changing. That's what's typical if we're in an air mass that's controlling our weather. Air mass temperatures for around here, well, air that's been around here, that's what we're used to. So we don't pay much attention to that. But if air comes in from our north, that's typically colder air, and we notice that coming in. Or air coming up from our south is warmer air, and we notice that as well. So we think of polar air masses as ones coming from the North Pole down towards us, and tropical air masses as ones coming from closer to the equator to us. Moisture, maritime, that means ocean, having to do with the sea. So maritime air mass would be an air mass where the air's been sitting over the ocean for a while. A continental air mass is one where the air's been sitting over the land for a while. Okay, not too hard to figure out. For example, if we had air that was sitting over a warm area of the ocean, let's say the Caribbean Sea, well, the ocean is wet. Yep, you knew that, but that means the air above the ocean is going to tend to have plenty of evaporation, and that air is going to be relatively humid. So our maritime air mass will be a humid air mass. Our continental air mass sitting over the land is not water. So we'll have less water to evaporate, and as water condenses, that continental air mass will tend to be drier. Similarly, not too hard to figure out, our polar air masses will characteristically be cool, and our tropical ones warm. Okay, so in an air mass, the weatherman can take a break. It's basically the same weather as yesterday. But along comes another air mass. And at the front, the boundary between those two air masses, things are changing, and weather will change, and sometimes maybe even get stormy. Just as we had in the ocean, different masses of air with their different densities tend to not mix very well. And so we get boundaries. And again, just as true for water, less dense air will tend to move up and over the other. Our different types of fronts. Cold and warm fronts are both named for the type of air that is moving in. So a cold front will be when cold air is moving in, symbolized by the blue triangles here. A warm front is when warm air is moving in. And then a stationary front is when we're sitting at the boundary between two air masses and they're staying in place. So we're at the boundary for a while. Sometimes you can see evidence of a front. Here we have a relatively straight line along that edge of the storm clouds moving in. That looks suspiciously like we're looking at a front. Also like it's a good time to get inside the car and with the windows all rolled up. Of course, if there aren't clouds, you can't directly see something going on, but fronts often are somewhat breezy. So if you've got a windier day than usual, that suggests you've got a front coming through and you may see changing weather. Cold fronts tend to be relatively steep coming in. As that cold, denser air pushes in, it's pushing the warm air up and out from in front of it. And so the boundary between them tends to be steep, and air is rising relatively fast in front of that. The warm air is pushed up relatively quickly. If that warm air is also humid, rising moist air cools, hits the dew point, makes clouds. Rising air puffing up, that's our cumulus clouds. Often, with the fast rising air there, we can make strong thunderstorms. A whole line of thunderstorms along the front of a strong cold front is a very common phenomenon. As the front's approaching, the wind is typically blowing towards the front because of the rising air in front of it, and you have low pressure out in front. Once the cold front has gotten past you, then the winds are blowing towards the front the opposite direction. So you have a change in wind, and also cooler air tends more to sink, so you have high pressure behind that cold front. Warm front, when it's the warm air that's moving in, well, the warm air is already moving, it can kind of slide up over that cold air that's already there. It doesn't have to shove the cold air up and move under it. So a cold front tends to have a more gradual slope as the warm air moves over the cold. So we've still got rising air, it's getting colder, making clouds, but it's not rising nearly as fast. And so typically this is more gradual. So as a warm front's approaching, you'll start to notice, there's some cirrus clouds up high starting to appear. And I'm seeing some clouds a little lower now, maybe alto stratus. And so we build up the stratus, and that's a wide layer of cloud, and we may get some rain or drizzle or snow depending on our temperature. But typically this is more moderate and spread out over a longer period of time, unlike the quick storms of our cold front.